Welcome and a very good afternoon. Today I will be presenting my article topic called Enhanced Active Corrosion Protection Coatings for Aluminum Alloys with two corrosion inhibitors co-incorporated into nano containers. So first of all, there are a few questions that have been raised from the article and will be brought back later on in the presentation, which is how to better improve the protective performance of organic coatings. Will a combination of inhibitors and protective coatings raise the protection of an alloy? Can the addition of two or more inhibitors further enhance protective performance of coatings on aluminum alloys? And, according to the research conducted, what is the optimal amount of inhibitors that will protect the aluminum alloy best? So we'll go straight into this diagram over here. We're going to refer to the steps down here. So first of all, the weld plate is set up to contain the 3.5 WT% sodium chloride solution with respect to concentration of BTA and BT or combined mixtures. So if we look at this, the first row over here actually only contains the front of the blue one over here is only just sodium chloride without any inhibitors, while over here is just a concentration of only BTA and BTA solution. With the absence of MBT and vice versa over here. So down here is only going to be MBT solution. Meanwhile, the middle over here is going to be the mixture of both MBT and BTA, and we'll see how this will actually affect how much concentration actually affects the corrosion rate. Then inhibitor mixtures are then dropped onto the AA20243 sheet. After 24 hours, we'll go through the grayscale process to accumulate the models. So basically, from here, the dropper, and we'll use a dropper to drop it onto the alloy sheet. This is our alloy sheet, the AA and AA sheet. And then after 1 day, we will transfer the images for image processing, and then we will get some images that will help us calculate corrosion ratio. This is a very important formula that we are going to use later on. So corrosion ratio will be calculated in the process of producing the molecular models. I'd like to bring your focus now onto these three images because they're very important. So this is the first one, the confocal laser scanning microscopy image, which will be converted into a binary figure processed by PyCharm. So the formula previously will use that formula with this picture to further get this picture over here. As you can see, corrosion rate is highest at this red point, while the least is down here, the green. And we'll see which ones are going to be the least and most later with the results in the next slide. So over here we can see the article's findings from the picture previously I've shown. So for A, this is the graph shown. This is for B, C, D, E, and F. So as you can see from the collective graphs shown, that D actually yields the best results, because we can see here from the phase stage, it's actually the highest as compared to the rest. Compared to the rest, the D actually has the best results in terms of the bold plots, and the amount of BTA and MBT. The most optimal amount is, according to the experiment, is 0.5 grams per liter BTA and 0.1 grams per liter MBT. So this is the optimal amount of inhibitors used to protect the aluminum alloy. Also, keep in mind that this experiment is actually repeated 3 times, so it will yield the same results 3 times. So this is quite a very solid finding. So we go back to the questions that are posed earlier, where we asked how to improve the protective performance of organic coating by adding healing agents such as monomers and polymers with the coating to greatly increase the protective performance. And the second question was, will combining inhibitors and protective coatings better protect the alloy? Yes, it can. Yes, inhibitors plus coatings definitely help and definitely work better as compared to just coatings or just inhibitors. And then inserting 2 or more inhibitors to coding. And the question previously was that can 2 or more inhibitors be better at increasing protection performance? Yes, it's actually better to add 2 or more inhibitors because, as we saw in the previous picture, the ones with only one inhibitor are actually yellow zones, while the ones that are a combination of both are green. And then, according to the research conducted, what's the optimal amount of inhibitors used? As I've stated it in the patent just now, 0.5 gram per liter of BTA and 0.1 gram of L per liter of MBT is actually the optimal amount of the solution to protect the alloy sheet. So this is my article link. That's all from me. Thank you.